Hi there, how are you doing? In this video series that I want to begin, I'd like to draw the Kenyan flag, which is here, using Python. And I think that this will be a really illustrative project of a lot of the things you can do with Python. And it's just going to be step by step. So I'm going to use the Turtle library. So if you've come across the Turtle library, you'll see that it's good for drawing. So you can draw basic shapes, so like rectangles and circles and so on and so forth. But what's going to be challenging about this project, or interesting about this project, is there are a lot of geometrical shapes that we have to figure out. So for example, the shield in the middle, the spears, there's a little thing here in the middle. And if you really think about these are rather non-trivial shapes. So for example, how do you draw the shield? So if you wanted to draw the shield, you have to draw a curve like that. Now it turns out that this is an interesting curve because it has a certain radius. Okay, so we can actually specify that this has some radius, but all we are given is a couple of dimensions of this shape. So for example, here we know there is a certain width here. Okay, so if we looked at this here, that has a certain width x, and this shield has a certain height here, y. So I'll just call this y to keep this simple. Okay, and our goal is, how can we actually draw this whole shape? So there are many things we need to know here. How do we calculate the value r? So we know the shield has a height here. This value y here is equals to some relative dimension of 48, and this has a width of 24, meaning that this has a relative dimension here of x here, which is roughly 12. So suppose you knew that x here was 12 and y here was 24. What would be the value of r? We have to work that out. The other things that would be interesting here would be to figure out if I were to draw this. So whenever you're drawing anything with the Turtle library, the orientation of the turtle has an impact on how you draw. So for example, by default, I think it assumes that it starts off with a bearing of heading towards the east. This is 0 degrees. And so you'll usually see some little triangle like this. And your goal is actually to draw a circle. So it'll start from the bottom and draw the circle going around. But if you notice, to draw this, you're not going to be starting from an orientation of 0. You're going to be starting from an orientation that is actually at some angle like that. And when we work it out, we'll see that there are a lot of interesting dimensions that need to be calculated. So what I'm going to do is I'm going to break this down into a number of steps. We're going to build a library that will allow us to draw this, and then we'll do a bit of some maths. And it's not complicated maths, it's actually quite straightforward maths. A lot of it is high school maths, and it'll be a great way for you to remind yourself of some of these geometrical ideas. So one of the things we'll do is we create a library which will use object-oriented Python, so OOP Python, to draw shapes. And then along the way, we may actually figure out how to do this using some of the key ideas in OOP. So for example, in inheritance, and we're going to use some polymorphism. So it's going to be a really instructive project. Okay. The next thing we're going to do is we're going to do a lot of derivations. So from first principles. So we're going to do a lot of derivations. How to draw custom shapes. So for example, right here at the center, we have an ellipse. How do you draw an ellipse? Well, we're going to start off from the equation of an ellipse, which is x squared over a squared plus y squared over b squared, which is equals to 1, which is equals to, yes, is equals to 1 actually. And we're going to figure out how to actually then come up with an ellipse class which can draw an ellipse in different orientations. And it turns out, and that's interesting, is that a circle is just a special case of an ellipse. A circle is a case where a squared is equals to b squared, which is equals to r squared. Okay, so a squared equals to b squared is equals to r squared. Okay, and then we are going to draw curves. There are going to be a lot of curves. And there are special kinds of curves. So one is we're going to figure out how to calculate these curves here, like this one here. So they're called arcs, okay? And whenever you deal with arcs, you deal with several things. So one thing is we need to figure out angles, we need to figure out the radius, and then one of the complex things is we're going to also deal, so these are the curves, we will also deal with things called Beziers. And these are fancy curves which, given a certain number of points, we can make sure that you can connect a smooth curve between those points. So for example, suppose I had a point here and a point here and a point here. How do I draw a smooth curve based on those points? So suppose I call this P0, P1, and P2, and my goal, since suppose we joined all these points together like this, and our goal is to try and figure out how do we draw a nice smooth curve that goes like that and connects those 3 points. So this is what I'm done here. It's rubbish, but then you get the idea. And we've done this before. You've probably seen this before, where you have points and then you draw. Let me pick a different color here. I'm going to pick something like green. So suppose you drew a straight line here, and then you draw another straight line from here to here, and you draw another straight line from here to here, and you draw another straight line, and so on and so forth. And you've probably seen this kind of string art. These kind of curves are called Bezier curves, and they are really nice to allow you to figure out smooth curves between points. And I think that's one of the things that you see featured here. Let's go back to using blue. The spheres require Bezier curves. So these are arcs here. This is an arc. This is a Bezier, B-E-Z-E-R. This is another curve here. Here we have an ellipse. And we're going to build all these from scratch. And by the end, we're going to have a nice GitHub repository that has got everything, which when we call the shapes, we'll end up with a Kenyan flag, either just by throwing the shapes onto the canvas or by actually drawing them, line by line, showing the shapes. So we'll start off with, in the 0th one, I'm going to show you just how the turtle library works. Simple examples of how to draw rectangles, triangles, circles, and so on and so forth. So if you're interested in learning more about Python programming, how to use a turtle library, how to do object-oriented Python, and how to then build from that, how to do some mathematical derivations, very simple mathematical derivations, but you need to pay a lot of attention, how to calculate angles and radiuses and so on and so forth, then stick around. And I hope you enjoy this. I'm going to create short videos, one at a time, just to build from beginning to the end. So yeah, just subscribe and find out more about how we can use Python to actually do something cool like this. And if you really like this, then I can make more projects on how to do more complex things. Okay then, bye.